Today we're going to talk about decimals and fractions that are greater than 1. So far we've been talking about decimals and fractions that are less than 1, such as the number 0.36, which can be read as 0.36 or 36 hundredths. When I read it that way, it makes it really easy to write it as a fraction, 36 hundredths, because the number 36 is ending in the second position, the hundredths place. 36 is ending in the hundredths, then I know that the fraction is 36 hundredths. I know that this number, 36 hundredths, is less than 1 because there's no wholes. Okay, if there was anything in the ones place, that's how many whole items I have. And in the fraction form, if there's no mixed number, so there's no whole number out here in front, then I know there's only the fractional part, which is a number that is less than 1. Have a look at these two examples here, 3.2 and 6.74. Okay, I can write this 3.2 as this means I have 3 wholes, and my decimal is the and, so this is 3 and 2/10. I would write it this way as a mixed number. The mixed number shows me that I have 3 wholes and I have a fractional part as well. That's what the decimal tells me as well. I have 3 wholes and I have a decimal part as well, 2/10. Okay, look at 6.74. It tells me that I have 6 wholes and 74, and the 74 is ending in the hundredths position, so that's 74 hundredths. This same concept applies to money. When you see $5.28, what that really means is you have 5 whole dollars and you have 28 hundredths of a dollar. In other words, 28 pennies or 28 cents. It takes 100 cents to make one more whole dollar. Okay, that can also be written as 5 and 28 hundredths, like I said, or we can write it in decimal form as 5 and 28 hundredths. So the number that is in front of the decimal, this number here, tells you how many whole parts you have. And the part that is after the decimal tells you how many, the fractional part, less than 1 whole. So how would you say this measurement? Well, some people may say 3.45 meters, and that is true. How would we write this as a fraction? Well, it's 3 and 45 hundredths, right? There are 100 centimeters in a meter. So when we have 45 hundredths, that means we have 45 centimeters. So what this really means is we have 3 meters and 45 centimeters, because there are 100 centimeters in a meter. So this 45 hundredths is 45 of those centimeters. Okay? So it's fine to say it as 3.45 as long as we recognize the fact that that 45 hundredths is 45 centimeters. We're going to write these fractions as decimals. So this fraction is 3 and 4/10. We would say it the exact same way as a decimal, but we would write it as 3 and 4/10. 4 in the tenths position, the first position after the decimal. Okay, 6 and 15 hundredths. 6 and 15, ending in the second position after the decimal, because that's the hundredths place. 6 and 15 hundredths. Okay, the next one is 20 and 7/10. We would write that as 20 and 7 in the tenths place, the first position after the decimal. 365 and 214 thousandths. 214 has to end in the thousandths position. That's the third place after the decimal. Tenths, hundredths, thousandths. Right? Is this decimal written correctly? 9 7/100ths. No, it is not, because this says 9 7/10, doesn't it? How would I have to write 9 7/100ths? 9 and 7 has to end in the hundredths position. That's the second place after the decimal. So there's a place here, and then the 7 goes there in the second position after the decimal. So what would I need to hold this place in the tenths position? A 0, right? Okay, remember zeros are your placeholders. So this is 9 7/100ths in the second position after the decimal. Okay, we've got some decimals here, but we have to identify first of all, which of these decimals would be a mixed number. In other words, which of these decimals have a whole or some whole parts. And then once we identify those, we're going to write them as mixed numbers. Okay, well, would A have any whole parts? Right. Any digit in the ones place tells you how many holes you have. So yes, A would. Does B? No. This decimal is less than 1 because there's no holes. 0 in the ones place. What about 7,820 decimal 0? Yes, we have some holes. Do we have any fractional parts? The fractional parts come after the decimal. No. So no, that would not be a mixed number. What about 200 decimal 004? We've got whole number parts, 200 of them, and we've got fractional parts. So yes, that would be a mixed number. What about E? 0 decimal 001,001. There's no whole parts, so no, it's not a mixed number. So we only have 2 there that are mixed numbers. Let's see if we can write them as mixed numbers. So 3.06 means I have 3 holes and 6 second position after the decimal. That's hundredths, isn't it? 3 6/100ths. Okay, what about 200 decimal 004? That means I have 200 holes and 4. What position is that 4 in? Tenths, hundredths, thousandths. Right. 200 and 4 thousandths. What would be the largest digit I could put in this first position after the decimal? In other words, that's the tenths. What's the largest number I could put in the tenths place? A 9, right. So 0.9, that's the largest number of tenths I could have. Is that number greater than 1? No, because there's no holes, right? There's 0 holes. So 9/10 is less than 1. Okay, let's look when we have tenths and hundredths. The second position after the decimal place is called the hundredths. What is the largest number of tenths and hundredths I could put on those 2 blanks? 9/10 and 9/100. 0.99. Is that number greater than 1? Well, no again, because I have 0 in front of the decimal place. That means I have no whole parts. I have just fractional parts. 99/100 sounds like a big number, but it's not even 1 whole yet, is it? Because I have no whole parts. The number in front of the decimal gives me how many whole parts I have. Well, then look at this great big huge fraction. Is this number greater than 1? Well, again, no. I have no whole parts, do I? So even though this number looks really, really big, it's very, very, very small. It's very close to 1 whole, but it's not greater than 1. There are no whole parts. Let's try a couple of word problems. Kyoko bikes 2 3/10 kilometers to school every day. Write this distance as a decimal. Well, 2 and is the decimal, 2 3/10. Where will the 3 go? In the first position after the decimal. That's the tenths position right there. 2 3/10 kilometers. That was pretty easy. Let's try number 2. Lined paper comes in packs of 100. Carl used 356 sheets of lined paper. How many packs of paper did he use? Write your answer as a mixed number and as a decimal. Okay, well, he used 356 sheets of paper, and the paper comes in packs of 100. Oh, 356 hundredths. Okay, so how would I convert this improper fraction into a mixed number? How many times does 100 go into 356? Well, 3 times. How many are left? The 56 out of 100 sheets that he had. Okay. Remember, I can do, once I've converted it, I can do a really quick check in my head to make sure that I've converted it properly by multiplying 100 times 3, 300, and add on the 56, 356, and it should get me back to this number, right? Then I'll know that I've converted it correctly. Okay, this is, he used 3 packs of paper and 56 sheets out of 100 in the fourth pack. How would I write this as a decimal? 3 and 56 hundredths. 56 ending in the hundredths position, the second place after the decimal. 3.56 packs of paper. In other words, just over 3.5 packs of paper, right? Okay, and the last one, the length of Ted's room is 3 meters and 12 centimeters. Write the length in meters as a mixed number and as a decimal. Remembering that 1 meter is 100 centimeters. The reason they're telling us that is because when they've given us the dimensions of his room as 3 meters and 12 centimeters, that means I have 3 meters and 12 hundredths, right? Because centimeters are, it takes 100 centimeters to make a meter. So 12 centimeters is 12 of those 100 centimeters that make a meter. So 3 and 12 hundredths of a meter is how long Ted's room is. Okay, that's the mixed number. How do we write this as a decimal? 3 and 12 hundredths. 3 and 12 ending in the hundredths position. 3.12 meters is how long his room is.